This Amateur Radio Roundtable is brought to you in part by ICOM America. Well, good evening. This is Tuesday, October 24th. Got a good show for you tonight. We've got Martin back with us again. And tell you, if you want to ask questions or learn things, he's the guy to do it with. And we'll open the phone lines during our segment with Martin tonight. Emmett Hohensee, W0QH, the Chief Engineer of Radio Waves, was going to be with us tonight, but guess what? They had a fiber cut in his neighborhood, so his internet fiber got cut, so he can't be on. So in a couple of weeks, we're going to talk about some of the things he's doing. We're going to get him back on the show. And we're going to talk about, he's got a project where he's doing some work with drones, I think in Florida. I won't tell you exactly what he's doing with them, but it's real interesting. And then we're going to talk about, hey, winter's coming up, how to get ready for winter with your antennas and everything. And I think it'll still be a great show there. So we'll have him back here with us in a couple weeks. Katie's out tonight, Dave's out tonight, but we're still going to have a great show with Martin here. Just want to make a quick announcement. People listening on WBCQ, International Shortwave Station, on 5130 kilohertz. You're welcome to join us on the internet. If you have internet connection, you can go to w5kub.com, w5kub.com, and you can join in and watch the video, and you can join in the chat room. And for everybody in the chat room, if you will, at the top of our page in our menu, you'll see a Facebook link, and we'd like for you to click on that Facebook link and join our Facebook group for this website here. We've got about a little over 6,000 people now in our group, and it's growing. So please join our Facebook group and help us spread the word. And we're so happy again that Martin's with us. And oh, one other announcement. We have a ham that just got his extra. He upgraded. Jason Bentley, KE4FRI, just upgraded to extra. Kathy, would you look and see if KE4FRI is in the chat room? And oh, hey, I've had the show a couple weeks without her, and it's not as good when she's not here. So Kathy's back with us, helping out here again to put the show on tonight. So congratulations to Jason Bentley, KE4FRI, got his extra class. Okay, he's not in the chat room. He's probably on the HF bands using that new license. So I'm going to go, let's go over to Martin here, and we're going to check and see what Martin's doing. And let me bring Martin in here. Here we go. Hey, Martin, how you doing tonight?
Oh, I'm doing great. How you doing, Tom?
I'm doing pretty good. Let me adjust your picture just a little bit here. I'm gonna get it adjusted. Okay.
Okay.
So, Martin, man, you must be liking us to come on here. I mean, this is about the fourth week you've been on. Are we gonna be able to keep you? Or are you getting tired of us?
Oh no, I'm enjoying it. You know, if I say I'm going to do something, I'm going to do it.
Well, all right. Well, that's great. Let me get your name up here. There we go. Well, so hey, Martin, you know, tonight, and we're going to open the phone lines to everybody out there. But you know, I was down at MFJ again this past weekend, and you know, every time I come down there and we look around, I learn new things and see things I never saw before. And you know, I brought Walter, my pilot friend, down Friday. He missed the 45th anniversary, and you were just great to take us around to all the different MFJ companies there, and you bought us a great lunch there at Obie's, and that was really really good there. So thanks a lot for your hospitality.
Oh, I enjoy y'all coming down here, and Walter's a very interesting guy, and you know, those red beans and rice. I think Walter had those too. I mean, they were.
Yeah, he did, and the sausage that came with that. My goodness, that was like 3 meals. Oh, it was really good. But again, thanks for your hospitality there. Well, you know, some of the things that amazed me again when I was down there is just watching you guys, how you put so much work into these products. And I noticed that you had built some special machines that did a lot of the building of components that you used to buy. And I just want to touch on those a little bit tonight. Let's talk about antennas tonight. Let's talk about amps. Let's talk about SWR. Let's talk about everything tonight.
That sounds good to me. Well, you know, being down here in Mississippi is different from being in some big city. You know, we can't go across the street and get PC boards made, or go down the corner and get cabinets made. And, you know, we ended up doing as much as we can because we have to do it down here.
Well, hey, boy, I wish I was closer. I'd be down here every week looking around. You guys would probably get tired of me. Hey, just very quickly, I do see in the chat room, KE4FRI, you said thanks for the mention. So he is in here tonight. He's not on HF bands. He must think our show is more important. So he's with us tonight. That's a new extra. Jason Bentley.
Well, glad to hear that you're on, Jason.
So, you know, I was looking at, and we walked through your facility, and there are so many parts now that you actually make. I mean, people probably think that you order parts and just assemble these units, but some of these things you kind of build from the ground up. And one of the things that impressed me a lot that I looked at was this. Here's a picture I took. This is of a rotary inductor. Let me see if I can get a better picture. I don't know if I can or not. Yeah, this is a rotary inductor here that it's made out of flat, I don't know, flat, I'm not sure.
Solid copper.
Copper, flat copper. Now, you guys have this thing silver plated too, don't you?
Well, we do. You know, we start off with a row of flat copper strip, and then we built a machine to edge wind it, just like what you see there.
Now I've got a picture of that, and I want to show people. And what we're talking about here is, you know, you take a little flat strip of copper like that. It's real easy to roll up one direction, but you guys are actually rolling it, I'm going to say, in a 90-degree plane from the way it should be rolled. And I think this is a machine that you guys roll it on right here.
Well, it is, and that's a machine that we built. That at the upper top of the picture, you see that row of copper strip, and then once it goes through the machine that we built, it becomes edge wound. It's kind of like a little slinky, and it's made of solid copper. And once we roll it and cut it to the approximate length, we sent it out to have it silver plated, because there's too many EPA environments, or too many EPA regulations that we have to conform to, so we send the silver plating part of it out.
Well, yeah, and you know, people, if they, and there are already questions in the chat room about this, but you can see the copper strip. Now, I wasn't sure it was copper. Of course, copper is a fairly soft metal. But again, if I tried taking that strip and bending it the way you bend it, it would just bend all up and crinkle up, and it'd be the biggest mess. But you guys, somehow, with this machine you built, you can roll that copper at a 90-degree plane and come out with some beautiful windings like this, and then you have them silver plated. And you built this this inductor here. Tell us about it. This is constructed, I think just about every part in here is constructed by you guys.
Well, yeah, it is. You know, we try to find a supplier to make that edge wound coil for us, but we couldn't find anyone that would do it at a reasonable price, so we decided to build our own machine and do it ourselves. But yeah, if you go, yeah, that's a good picture. You see the long copper strip that goes along the coil. There's 4 of those, and they're slotted to space the coils and hold them together. And then there's fiberglass end plates. Now, if you go back to that first picture that you showed when you started, okay, look over almost in the middle of the picture. There's a disc about 2/3 of the way down that's attached to a square-looking brass piece, but there's 2 discs that clamps onto the inside of that edge-wound silver-plated copper strip. And there is a very strong spring that compresses those 2 discs, that's compresses on both sides of that edge-wound copper strips.
Well, I've torn some old military equipment up before, and they had a little roller like this on their thing, but they just had a little wheel there with a little groove in it, that rolled around. Now, you guys, like you're explaining here, you've got 2 different discs that are spring-loaded that squeeze that that inductor when it turns, doesn't it?
That's right, and it squeezes it very tightly, so the contact is a very good contact. Now, that contact that you're talking about, which is a wheel, is just tangent to the wire or the conductor, so there's only one tiny place that makes contact. This one, the one that we have here, compresses both of those discs together, so you have very good contact on both sides, and it maintains that pressure wherever you wind it. And if you look that that disc is attached to an arm. Yeah, you can see the square piece that arm, the silver-plated arm that wheel is connected to. So it makes very good contact on that silver-plated arm, and then that whole arm is connected to a square piece of solid brass that's connected to the center. And we make all of those parts. That center, that brass square piece.
Yeah, you make everything. The ends, the fiberglass ends, everything, right?
Fiberglass part of it. If you look at that shaft right in the middle, that is a self-adjusting
bearing. Yeah.
So it pivots within that bearing, so there's never any binding. It's a very smooth operating roller inductor. This is a real roller inductor.
And now, people are saying why flat instead of round. Now, you also make. We'll show in a minute how you can make the wire coils here. But right now we're talking about this flat one. And is there an advantage to this flat? Will it handle more power? What's the advantage of this?
There's several advantages of it. One is there's huge amount of mass, so it can dissipate the heat because of its area that is exposed to air, so it can handle lots of power, and the contact that is on both sides of it allows it to handle a lot more current, and because it's silver plated, it can handle more current under conditions where a non-silver plated would corrode. Now, this shows the ATR30, a Maritron antenna tuner that a version of that roller inductor is mounted in. Each one of those capacitors is 500 picofarads of capacitance, which is twice as much as what normal antenna tuners use. And notice how big that balun is on the back side of it.
I was looking at that. Now that balance, I guess that makes this tuner, what, matches like a balance load? Is that what that's for?
That's what it's for. Yeah.
But that
So
tuner, is that a balance only, or will that tuner tune both balanced and unbalanced?
Oh, it tunes both balanced
Okay.
and unbalanced.
So, that's interesting. So that's one thing I saw that just really impressed me, how clean and pretty this thing looks. And you take some pretty crude, strips of copper, and you form it, and you silver plate it, and you build all these parts. One of the questions was, what's the ring for there? Is that a little 6-meter loop or ring or something, or what was that?
That's a very good question. We put that loop perpendicular so the magnetic fields don't couple, and it's used for 10 meters. It makes 10 meters work much, much better.
Oh, okay.
If you look on the other end, you'll see a copper strip, and that's for carrying the heavy current. Now it's on the other side.
Okay, I don't think I have a picture of the other end.
Oh, no. Just go back to that picture, the original one.
That one, let's see, that one?
No, the first one that you...
Oh, that one right there. Yeah.
That one, yeah. If you look on, I'm looking at my computer screen. If you look on the left side, there's a copper strip that's sticking up toward the left. Anyway, that's you can see how the end of that conductor from the roller is attached to it. Anyway, that's for a very high power. That's in a tuner that will handle 2,500 watts continuous.
Yeah, that's a nice tuner.
Those fiber end on each end of it is what is used to mount it in the tuner.
Yeah. Now let's talk about the other coils you make. And I was surprised there again. Used to these. What was this? Dubler or whoever made these coils.
That was.
I forget the name.
Well, I forgot what their name is too. It was. I remember.
Well, that's okay.
Take next month to remember, but I will remember. They were called mini ductors.
Yeah, now this
B&W.
Yeah, well, B&W made one. Now, this is a jig or machine that you made that winds these coils. And tell kind of how these coils are made and how this thing puts that plastic on there.
Okay. Well, you can see where Tom's thumb was, the plastic strip. Okay, that is a... and now that coil is on top of a mandrel, and that mandrel is made into 4 pieces. There's 4 quadrants that forms a cylinder. And if you look just below that coil, not where that long strip, the black strip is, but just below there, that's one of the places where you put one of those lucite plastic strips that you see in the picture there now.
So you'd put 4 of those strips in a little groove there.
That's right. There's 4 grooves, and we use a very high-tech method of keeping those plastic strips in place, and that high-tech technique is a rubber band.
Oh man! Well, keep it simple. Keep it simple.
Yeah, it just holds it on there, and but those 4 quadrants is expanded by a cone that goes into the end. If you look on the right end, you can't really see it, but there is a cone-shaped piece of metal that goes into it and expands it.
Okay.
That's why you see that very dark strip just below the coil. It's fully expanded when you put that cone into it. And then what we do next is there's a coil of wire. Yeah, we put the plastic piece in the groove and put 4 of them in there.
Here we go. That's what I'm looking for right there.
Yeah, that one. You see that big coil of wire above it? and just below it, you see a big copper disc. And then if you look in the middle of the picture on the right-hand side, there is a 600 amp transformer in there, and that big knob in the middle of that box is a rheostat that adjusts the current. And if you look on the left side of that box, you see those very heavy-duty black plastic cover wires that can handle the full 600 amps of current. Now that's attached to that disc. Okay.
Mm-hmm.
And what happens is that coil wire that's hanging above that assembly, we pass that electric current from that 600 amp transformer until that wire turns almost orange. It gets very, very hot. And then it's wound onto those 4 plastic strips, and it melts itself into those plastic strips.
So the wire gets hot. This thing is turning, and the wire, it gets very hot, and it just melts right into those plastic strips, and then you take it off.
Well, it's not quite as simple as taking it off, because as you wind it, it compresses onto that mandrel so hard that you can't hardly take it off.
Oh.
And that's the reason there's that black strip just below that coil. That's airspace.
Yeah.
It's 4 pieces. It's a mandrel with 4 quadrants on it. And on the right end, there's a cone that causes it to expand. Now, when you finish winding all of that, and the plastic has cooled off and set, then you remove that cone on the right-hand side, that entire mandrel collapses, and then you can slide that coil off.
Then you can slide it out, yeah. Well, you know, that was just some of that's a couple of things that really impressed me down here is seeing you guys make your own coils for your amps and your tuners, and it's, you know, they look good. I mean,
well, you know, we do that because we can't go across the street and get someone else to do it. Plus, if someone else is doing it, you know, they can come out and make a little bit off of it. So we decided that we ought to be doing it ourselves.
Well, I'm sure it helps hold your costs down. And I know, like for the input circuits that you put in your amps, the little tuned circuits, used to on the TV market, you could buy all these little coils with little slug tuned slug in there. And now that TVs don't really use those anymore, they were getting hard to find. And you guys even make your own coil forms and wind your own coils and put the slugs in there now.
Well, we do. You know, there was a time when we could buy those components, and as these guys that own these companies got older, they started retiring, and we couldn't get these parts. So in this case, what we did was we went up and bought all of their stuff, and we set it all up down here, and we can wind those coils and make the slug tune coils and just do everything ourselves.
So Martin, I want to jump over to antennas. I've never used one of these magnetic loops. I know they're getting very popular, and you guys make a lot of them now. How does a little small magnetic loop that small work? You know, let's compare it to a 20-meter dipole. It's surely got to be a little less, right?
Well, yeah. You know, the loop that we make, we've got 2 versions. One covers 20 meters through 10 meters, and one covers 40 meters through 15 meters. Now, let's take, for example, the 20-meter band. It's only 30 inches in diameter, and it replaces a dipole that's 32, 33 feet long. Mm-hmm, and that's pretty small size antenna, but it can perform just as well as a full-size dipole.
Wow.
Now, let me explain what I mean by that. The feed point resistance of a dipole in free space is about 73 ohms. And the radiation resistance of a loop that's 30 inches in diameter is about 50, 60 milliohms.
Now, milliohms, I've never heard the term used, milliohms, in all my electronics. That's getting really small.
That's very small. That's 0.050 ohms compared to 73 milliohms. So any resistance at all will cause that antenna to waste all of your power. So what we do, and we're the only people that does this, is to weld every connection. Every single connection is welded. There are no mechanical contacts, no rotating contacts, nothing. And when we do this, what matters is the resistance of that 1.05 inch aluminum tubing. We have reduced the resistance where on 20 meters we can get 62% efficiency. In other words, in a dipole, it's about 92% efficient. And what that means is if you put 100 watts in it, 98 watts is radiated, 98% efficient. Now this loop, the way that we build it, 62% efficient on 20 meters. So you put 100 watts in, you radiate 62 watts.
Yeah.
Well, that might sound like a lot of loss, but that really is not very much loss on the receiving end. 1S unit is about 6 dB. So this is less than 3 dB, less than a half S unit when you look at your receiving, so that nobody can even hear the difference between 6 dB and 3 dB. It's not even 3 dB. Now, most of these other loops that are made like with a piece of rounded coax or smaller material and plastic capacitors or capacitors that have rotating contacts, the efficiency is down into a few percent, if that high. I just, we could make products like that too, but we just don't choose to make products that doesn't work well. But so, anyway, in the capacitor that we have, every plate is welded. And let me tell you how we make a capacitor that has no rotating contacts. Okay. If you can bring me back in, I'm going to put my hand here.
Okay, all right.
Okay, I have my hand out. Now, if you take your hand and you place it over mine, directly over mine, like this, okay, over both hands. Now, you can see if I connect a wire where my thumb is and where this thumb is, you can see I have two capacitors in series where your hand over mine. Okay, now, if you take your hand and you slide it over my hand away from me, you can see that you have now a variable capacitor with no rotating contacts. And that's how we built that capacitor. It's a butterfly capacitor that we build here with no rotating contacts at all. Now, my two hands, if you look at the upper stationary plates and the bottom stationary plates, those are my two hands. And the middle plates, which is the rotor, is your hand that's moving away from my hand. And the connection is made from the top and the bottom section. And you can see that there's no rotating contacts. So in order to make a loop work and make it very efficient, you can't have any mechanical contacts. Now, and also the material that you use has to be very, very low RF resistance. And that's the reason we use a solid 1.05 inch aluminum tubing, which is the second best conductor after copper.
Well, you know, I'm looking at this, and you're with the impedance in the milliohms. I know other people probably bolt this stuff together with bolts and lock washers, and you got to think, I mean, if you're dealing with milliohms, that the connection of the metal there is going to affect, I mean, just a little bit of corrosion or no contact will greatly change milliohms. So it's interesting. Now, these loops here, are they plated in some way? They look real shiny.
Well, we polish them all up.
Okay. So that's interesting here in your loop antennas. You do all the welding just to keep that very, very low impedance down right where you want it, I guess.
Yeah, and that capacitor that you see there is for the version that covers 40 meters through 15 meters. Now, the version that covers 30 meters through 10 meters is about half that side. Now, if you look on the right-hand side on the end plate, you'll see a spring there.
Yeah.
That spring there is to eliminate any backlash. So when you're tuning it, you don't have backlash in tuning. And if you look on the left-hand side on that plate, you'll see mounted on that plate a red micro switch.
Yeah.
And that tells you when you're at the end of that travel. If you look closely above that, mounted on the rotor, there's an arm that when it rotates all the way out, it turns that micro switch off. So there's no power that can go to the motor. Now, in order to turn it for power to get back into the motor to go back, we put a diode across that micro switch so the power can flow in the other direction and go back. Now, the other thing to notice is those plates, which we punch out on our CNC machines, all of those plates are highly polished, so the edges are very, very smooth, so there's no arcing in it. And if you'll notice that on both ends, the stator plates are mounted very far apart because the voltages on between those two plates can get up to 15,000 volts, and up 30 amps can flow through there. And as we were designing this tuner, you could actually feel the path of the current flow through that fiberglass material just by running your finger through it. You could feel where the current was flowing that was heating up that fiberglass.
Well, that's interesting. All the things you have to do on that magnetic loop antenna to make that thing operate. Some days I'm gonna try one, but
you'd be surprised because when we were designing it, I had one at home. It was leaned up against, it was on the floor, leaned up against my couch, and I was running QRP, and I was working into Europe. Now, you know, during that period, we had better propagation than we have today.
Well, things were a whole lot better back in the old days, weren't they?
Oh, yeah. You know, we can talk Lots and
You
lots
know,
about old days. But
I'm going to jump into the old days real quick here, and we'll come back to the recent. But I've got some diagrams I picked out here, things we've talked about in the past. And, you were talking about your light bulb, your light bulb TR switch. And,
well, we used light bulbs for lots of things back in the old days.
Yeah, we did.
We could, we didn't have. Oh yeah, we didn't have meters or anything. Let's talk about this.
Now I don't know. That may not be like what you had, but it's the same principle.
Same principle. The only difference is on the right hand side, where you see that 8.2 picofarad capacitor. Okay, that wasn't in it, and that other thing, which I think is like a what do you call those things that break down and absorb voltages?
It's some kind of breakdown, yeah.
And on the left-hand side, that 10 picofarad capacitor, we didn't have on it, but all we had was that light bulb and those two diodes. And the antenna is connected on the right-hand side. That was connected to the transmitter and left connected there, like if you had a dipole up, and then on the left-hand side where it says receiver, that was connected to your vacuum tube receiver, because that's all we had back then were vacuum tubes.
So guys, after you're watching this thing, what you've got here on the right side, you had like a antenna. Your transmitter always stayed connected to the antenna, and when you were receiving, it would go through, the signal would go through that light bulb to the receiver input. But when you transmitted, this little device here kept burning up, and that's what we used to switch. No relays or anything. Or that's what Martin used. Now, I didn't get this sophisticated, Martin.
Well, this thing was built on the top of an old Maxwell House coffee can lid. And then, you put the can over it to shield it. But that was like a Christmas tree light bulb is what we used back then. When it was cold during receive, the resistance was low. Now, when you transmit it, that light bulb will light up, and the resistance of that light bulb got very high, and that's what protected the receiver from the transmit power. And those two diodes, whatever transmit voltage that got through that light bulb was shunted by those two diodes and protected the receiver. And that was a totally fully automatic TR switch where you didn't have to take an alligator clip and move it from your transmitter and your receiver, or use a double pole double throw knife switch.
Well, I was about 4 years after you, and we really got modern. Here's what I used. This is a self-contained all-band electronic TR switch. Look at there. That's what I used to switch. Same principle. You had a T connector, and your transmitter is always connected to the antenna, and then it goes through this tube, and then it connects to your receiver. So that's what I used there, and it was quite more complex. There's a diagram. It wasn't too much in it though, but basically it did the same thing. It just took a lot more parts.
I tell you, that was a very sophisticated product compared to that little coffee can, and I'm sure that worked much better.
And if you look closely, you can't hardly see it here, but if you look real close, you can see a little pencil mark around each component. And when I'd put a resistor in or a capacitor in, I'd circle it, so I'd know I got all the parts in. So that's kind of what I did. Hey, you mentioned once before using twin lead or open line, and how back then we used light bulbs again for checking or tuning, I guess, your antenna or whatever. Here's a picture. This is using 300 ohm twin lead for the antenna, or even today this will work. You can use ladder line. But tell us about this little what you did here.
Okay. Well, you notice in the upper right, you'll see that this picture came from a radio handbook from 1951.
Mm-hmm.
And that was not long after we had television, and from a and there weren't that many TV antennas, and most of us who wanted to watch TV had to use an outside antenna up. We had one like 50 feet. We got our first TV in 1954, and we had a TV push-up pole that was up about 50 feet.
Mm.
And from the antenna, there were Yagis back then. You had to rotate it toward the TV station, and there were 2 or 3 stations. We had a station in Jackson, 2 stations in Jackson, Mississippi. And I'm talking about, this is where we grew up in Hollandale, Mississippi, which was in the Mississippi Delta. But our main TV station was Jackson, Mississippi. It was about 100 miles away. And sometimes we could get a TV station in Monroe, Louisiana, which was even further away.
Oh, yeah.
But what you had to do was be able to get the signal from your antenna down to your TV set. And we used 300 ohm twin lead. They're like a ladder line or open wire line, but they were low loss lines. Okay.
Mm-hmm.
Now, in ham radio, we adapted TV twin lead 300 ohm ladder line for transmission. And because it was cheap, and coax was just beginning to become popular then. Well, we didn't really have any good way to tell when we were tuned up. So someone, and this was brilliant, developed a device that could tell us when we had our antenna tuned up. It was an SWR indicator. Basically, it was a piece of 300 ohm twin lead that had a little light bulb on each end, and the center of one side of that twin lead was soldered onto the transmission line from the antenna, your transmitting antenna, to your transmitter. And when SWR was low, one of the light bulbs, I forgot which one, would light up very brightly, and the other one would go dim. And then you had your antenna tuned up. Now, my Alma, oh yeah, that's a perfect picture. That's the way it was back then. And it worked really good. That's what I used to tune up my antenna.
And now, that's just another piece, that's just a little short piece of 300 ohm with a couple flashlight bulbs fastened to it, and it looks like it's taped. It looks like it's taped onto the other.
It's taped onto it, but notice that a connection to that flashlight bulb is connected to the twin lead.
Mm-hmm.
But my Elma, he was a radio TV repairman in Hollandale, Mississippi. He built let's see, what do you call these things now? But I can't remember what it's called, but it's a loop type, not a loop, but a like the old Johnson Matchbox for one band.
Oh, it's some type coupler or something.
Yeah, it was a coupler like that.
Uh-huh.
But the antenna was built out of soft drawn copper, and it was an extended double ZEP for 20 meters, 90 feet long, and basically 2 5/8 on each end of it, which would give you 2 to 3 dB of gain on 20 meters. But the impedance was such that you couldn't match it directly to a transmitter, so you had to use a very simple antenna tuner. And I used one of those twin lamp SWR indicators to tell me when I had the antenna tuned up.
Mm-hmm.
And I also used another light bulb with a few turns of wire near the loading coil of the tuner or the transmitter, so when it glowed the most brightly, you had everything tuned up. So without meters, we could do some of the things that a meter, which was much more sensitive, with just a plain old cheap flashlight light bulb or Christmas tree light bulb.
Oh, yeah. Okay, let's see. Let's take a quick break, about a 1-minute break. We'll be right back. We're with Martin F. Jew, founder and president of MFJ Enterprises. We'll be right back. Transceiver that's best suited for your lifestyle. ICOM offers a variety of high-performance and innovative products. See how you can make the most out of the contest season with one of these transceivers. Ideal for the ham on the go, the IC7300 is a high-performance HF transceiver with a compact design. Don't miss a weak signal with the combination of the waterfall function and a real-time spectrum scope. It has RF direct sampling, 15 discrete bandpass filters, a large 4.3-inch color touchscreen, real-time spectrum scope, and an SD memory card slot. The IC7851 will give you the competitive edge you've been looking for. Raise the bar and hear what others can't hear with the HF 50 MHz transceiver. It has reciprocal mixing dynamic range, a crystal clear local oscillator design, a spectrum scope, dual receivers, and a digital voice recorder. Can't wait for the IC7610? The IC7600 is still available and is at a great price. Following in the footsteps of ICOM's flagship radio, the IC7600 has an intuitive operation and the latest DSP technologies. It comes with a digital IF filter, dual DSP, 5.8-inch ultra-wide TFT display, and a high-resolution real-time spectrum scope. Visit www.icomamerica.com/amateur for more information on ICOM radios. All right, we're back with Martin F. Jew of MFJ here. We're going to turn the phone lines on, and hey, we're going to continue to talk about things. You know, Walter Rook, my friend, NR3V, has been down, and we've been trying to build a we've been trying to build a cobweb antenna, and there's so many variations out there. We're taking a little bit from everybody and mixing it all up and trying to do things differently. And you know, we're recording all that on video, and we're going to put together a whole segment on our experience in building a cobweb and letting you see how it worked out for us. Let me put the phone number up here. If you guys want to call in and talk with Martin, feel free to. Again, this is not for customer service. If you need to talk to customer service or you got a problem, call customer service. Check their email out on their website. But anything else, we'll talk to Martin about, and I'm sure he can answer your questions. So I'm gonna put the phone number up here. There it is. And you guys feel free to call in, and we'll take comments and questions from people. And Martin, I want to talk some about antennas. You know, we're building, Walter and I are building this cobweb antenna, and this is what the MFJ's cobweb looks like right here. Now this one it looks pretty large. I think this one has 40 meters on it, and that's a pretty big looking cobweb to me. But now you guys are selling this. Is that under the? Do y'all sell that under the High Gain brand, or?
It's on the MFJ.
Oh, okay, the MFJ brand. Okay.
Yeah, we really have. It's really. I mean, it covers 40 meters through. I forgot, either 10 or 6 meters. I think it covers 6 meters too. And the two elements on the outside is for 40 meters and 30 meters. Now the 20 meter through 10 or 6, I think 6 meters is pretty small, and there's an add-on kit that you can get if you want to add 30 and 40 meters. Now we're bringing out a bigger and stronger version that includes 30 and 40 meters, but it's a flat. I mean, if you look at the actual antenna, it's in one plane. It's just like a
Yeah.
flat square pancake.
Well, I can see the 40 meter and the 30 meter in there. Of course, the one at Walter and I, we're starting off with 20 meters. We're going 20 through 10. And yeah, that's nice adding that on. You do have to extend the arms out to get those on there. But tell us about this antenna now. When you wrap an antenna, a dipole, and these are dipole antennas that are wrapped kind of in a square. And if they'll notice on the left side of this antenna, those little black marks there, those are basically insulators that insulate the two ends of the dipole. And tell us what happens, Martin, to the impedance when you stretch a dipole out straight, and then when you bend it in a square, the impedance goes way down.
Okay. Well, if you take a normal dipole in free space, the calculated impedance when it's in free space is about 73 ohms when the dipole is fully stretched. Now, if you reduce the length of that in any way, by bending it, by using loading coils, by using capacitive hats, by bending it into a square, the impedance drops. It goes lower. And what we have in a dipole is a full size in a cobweb. What happens in the cobweb is that in a full size dipole, we bend it into a square.
Mm-hmm.
Now, when we do that, it just happens that the antenna impedance drops from 72 ohms to about 12.5 ohms in the real world. So each one of those bent full-size dipole is about 3.5 ohms. And if you look on the right-hand side, where all those feed points come together, it goes into a transformer that will take the 12.5 ohms, it's a 4-to-1 transformer, and transform it up to about 50 ohms. And then once we get it to the right impedance that matches your transceiver, we put an RF insulator at 1-to-1 balun to keep, I mean, it's a balance antenna, and that 1-to-1 isolator, the 1-to-1 balun, will convert the balanced antenna into a unbalanced feed point. So you can connect a coax directly to that box and run it right into your transmitter.
We've got an Ed on here, WB5ORT. He's building a cobweb, and his plan is to use a toroid, a 4-to-1 balun, and just turn it around backwards, where you go from the 12.5 ohms up to the 50. So I guess a balun will work turned either way, right? I mean,
yeah, that's basically what we're doing. The only difference is we're adding to that a balun, a 1-to-1 balun, an RF isolator that will convert it from a balance to an unbalanced, you connect a transformer. And let me mention that any part that you want from these cobweb antennas are available from us, including the matching box that has the 1-to-4 transformer and the balun built in together, and also all of those insulators that you see on the left-hand side.
So and that's a good point, Martin. For our viewers out there, you can buy replacement parts for any of your antennas, and if a person wanted to buy the matching the balun right there, they can just go in your catalog and order it, and it saves them the trouble to have to make it. One person asked in here, why backwards? I mentioned turning a 4-to-1 in there backwards. Well, typically your 4-to-1 matches your coax 50 ohm to 200 ohm. But since this antenna has an impedance of 12.5 ohms, you turn that balun around backwards and it matches 12.5, and it steps it up 4 times to 50 ohms. So that's why I was saying you'd turn it around backwards. And Martin, the one that and I showed you this when we were down there, the one that Walter and I are working on, we're going to try to do it without a balun at all, and we're going to try to maintain a 50 ohm impedance there by using like speaker wire or zip wire, speaker wire for the radiating elements. It'll still be a square like that, but basically one wire will feed all the way through, and the other wire, the split wire, will be cut, and that will become your where your coax connects, and then we short out the 2 wires on each side at a certain distance, kind of like the old gamma match, or kind of like a gamma match, and I referred to it the other day as a T. It's like a, but I guess it's, let's see, that's probably called a delta match. Wouldn't it be a delta match?
Well, it could be. I mean, basically, you go out far enough where you raise the impedance to a point that's acceptable. Can I mention another concept?
Sure.
Or another way to look at this whole thing that you're doing here?
Yeah.
Okay. If we take TV twin lead or 450 ohm ladder line or just open wire 600 ohms, and we build a folded dipole.
Right.
Okay, a folded dipole is basically a transformer. And it transforms it up to like 4-to-1. So let's take a piece of inexpensive 300 ohm TV twin lead and build a folded dipole. Okay, but instead, a folded dipole it's basically a 4-to-1 transformer. So
what 1/4 of 300 would be, what is that? 72 or 3 ohms. Yeah,
somewhere around there.
Yeah. Well, that's an idea too. And that's what Walter and I are doing. We're experimenting. We're trying to learn. We're trying different things, and that's what we want to show people. I can tell you right now, if you go out and buy all the pieces that you want to experiment with, you'll put almost as much money into the antenna you're building as you would if you bought one of these cobwebs. I don't know how Martin keeps his price down so low on those cobwebs, but the price will get up there. And then you also have the option when you're experimenting like that, you might put all that money in it, it might not work. So, well,
and you're right, and I appreciate that plug.
So it's interesting. This antenna really interests me. It's small. I thought about hex beam, but a hex beam is much bigger because the elements aren't folded around as much. Here's the hex beam. It's a lot bigger antenna, and my concern is how well the folded back cobweb will work. Boy, I'm reading on the internet, all these people that use the cobweb, how they're getting tremendous signal reports, and they compare it with other antennas, and it works just as well. And it's a small, compact antenna.
Well, it's very small, it's very compact, the cobweb, and it's almost omnidirectional.
Right.
And if you put a vertical up, a normal vertical that works against ground, you have to have some kind of a good counterpole system or a real ground system for it to be very efficient. And if you use an antenna that has a built-in counterpole system, it tends to be big and bulky. And this cobweb antenna is just flat and omnidirectional. I mean, it's almost an ideal antenna for someone who doesn't have much space.
Well, I was going to show Walter, and we were going to experiment. I said, Walter, before we even put a square wire around this thing, I said, let's just hang a dipole up. We made a dipole for 10 meters. I said, let's look at it and kind of get a little benchmark. I said, now let's just wrap it in a square around our X frame, and we'll just use a little duct tape and tape it on the elements, you know. And so we looked at a 10-meter dipole, and then we folded that thing. And I tell you, I didn't see what I expected to see. You know, I expected to see that impedance go down to 12 ohms, but man, it was all over the place. Either we had a loose connection, or the sun was and the moon was lined up wrong, or something. It didn't make any sense what we saw. We could not find a resonant point anywhere on that single piece of wire that we bent around. So I think that was our mistake. We didn't spend enough time to really work through that.
Well, you know, the impedance of an antenna is a function of how far above ground it is.
Right.
And it varies. It'll go up, then come back down as a function of how far above ground you are.
And you know, that may be true. You know, we had this 10-meter dipole up maybe 10 feet in the air, and we did see, you know, like maybe a 60 ohm or something, you know, and we saw a resonant point at 28. But when we bent it back in a square, we didn't see any resonant point, and I think the impedance was just terribly way off. But you know what? What you're saying is that might be in that configuration, that height above the ground just may not make it work.
Now, when you say resonant point, were you looking at the SWR, or what were you looking at?
Well, we were looking at SWR. We saw a dip down to about 1.2, and we saw an impedance of about 60-something ohms when it was stretched out, you know.
Okay, what you might want to look at is the resistive part and the reactive part.
Right.
Resonance is defined as when the reactive part is equal to 0.
Yeah.
And whatever the resistive part happens to be. So what you might want to look at is put it into the R and X mode and tune the frequency until you get X equal to 0. When X is equal to 0, then it's resonant. Now the SWR might be real high because the resistive part of it might be real low. And in this case, the resistive part could be around 12 ohms where X is equal to 0, and then the SWR would be above 4 to 1.
Well, we're going to continue playing with this thing, and like I said, it's mainly a learning experience, so we're going to try to document the steps we go through and just show people, you know, what our experience was. And we did put the lamp cord type speaker wire around on 10 meters into a square, and it did look good on the meter, whereas a single wire that went around did not. So, you know, different pieces, we're getting different indications, but we spent all afternoon making our support for it and the cross, you know, to put it on, and we're using PVC pipe, and you know, that's the sun's going to probably eventually crack it up, and it's going to come apart on us out there. So what we're doing is building a prototype, just a beta test, trying different things on it, and who knows, we may take 300 ohm twin lead and wrap it around it.
Well, you know, that's the fun of it. You know, you can, you know, ham radio is it's all about learning. You know, it's a learning hobby, and the fun is playing around and seeing how things work. And let me encourage anyone who is watching. I would love to talk to you. Call in.
Yeah, let's the number is on the
Text in.
screen, 901-286-1116. We're getting some questions in the chat room, but guys, don't be shy. You talking to a microphone all the time. Call 901-286-1116 and talk with me and Martin, and we might learn something here. Martin, one of the questions was, what's the advantage of the cobweb over a plumber's delight beam?
Well, if I understand right, plumber's delight beam is a 2-element beam. Okay, first of all, a 2-element beam is for one band, and it's directional, and it's a great antenna for the band that you want to operate on. But if you want to operate multiple bands and have a very low profile and not have to point it to anywhere, then a cobweb might be interesting to you, and is probably better compared to a vertical antenna that's omnidirectional and easy to put up. And the advantage of a cobweb over a vertical antenna is that you don't have to have any counterpause or ground, and it's very small, very compact, and very unobtrusive, and very lightweight, and it's less costly than a vertical antenna that covers the same bands.
Well, and I'm guessing a plumber's delight is taking a conduit or something and just building a simple beam like you mentioned, and a 20-meter beam, unless you've got loading coils, a 20-meter beam is going to be what, Martin, 33 feet wide?
Yeah, it'll be long.
33 feet wide for that element, and the cobweb, 20 meters, it's only 9 foot wide, so it's 9 foot on each side. So if you look at the study it, your cross pieces, your fiberglass cross pieces, they're about 6 feet on each side. And if you use the old formula you learned in school, a squared plus b squared equals c squared, that 6 squared plus 6 squared is 72 total, and the square root of 72 is, I don't know what's the square root of 72? 36, 72. Square root of 72. That's going to be about
8 and 9.
8 to 9 feet. So that's what the side is going to be. So each side is going to be about 8 feet.
Yeah, I like that.
All right, 901-286-1116. I know the phone line's working. I tested it tonight, so we got some shy people. What's the best? Here's a question: what's the best elevation above ground? I guess for a cobweb.
Well, cobwebs will work. I mean, they can work at very low levels, 10, 12, 20, 25 feet. They work well at just about any level. Let me mention 2 new antennas that we're coming out with. 10 to 11 foot boom. We have one for 3 bands, one for 5 bands. They're 2-element beams, 2-element Yagis for 5 bands on an 11-foot boom, and the elements are full size. I mean, it's the boom is very short, but on 20 meters is 36 feet total end-to-end element. So I mean, it's small in terms of a boom, but you get full-size performance because the elements are full size, and there's no power limit on them. It's a direct 50 ohm feed. It's under the high gain, the SR5 and the SR3. Brand new products.
Yeah. The question about how high to put the antenna a minute ago. You put it where you can put it, right, Martin? Us as hams, we don't always have the luxury. We don't always have the luxury of having living in a building that's got 25 or 50 floors where we can put an antenna on top, or You know, it just, and I found, you know, being a novice, you just put the antenna where you can, and guess what? It will work. And unless you've got that antenna at the optimal height, and you got the other one that you put up at 15 feet, unless you have those two antennas, you probably never notice a difference. You have nothing to really compare it to, you know. So, you know, Martin and we've been talking for several months, and my situation is I wanted a little bit better signal out there. You know, I hear these guys on there that sounds like they're running 10,000 watts, and their audio sounds like their AM plate modulation, and they've got these radio voices. That's the way I want to sound, but I probably will never get there. I had a tower and a beam, a tri-bander at my other home, and I just decided not to put it back up. I mean, I could probably put it up here, but I decided not to. And, you know, there is some maintenance and things you got to do to keep an antenna, you know, up and safe and everything. But you know, I found that I could talk to just about anywhere in the world I wanted to talk to with a wire antenna. And there's some really good ones out there, like delta loops or full wave loops, things like that. So I decided that I'm not going to put my tower back up, and I'm going to use wire antennas, but I still want to have a better signal. So in my case, I needed to use some type amplifier. I needed to get some gain, and the only way I could do it was with an amplifier. But people without an amplifier, they can probably get the same gain if they've just got a tri-bander up. So it's kind of a balancing act, I guess, depending on your circumstances, what you can do to get the best signal out.
Well, you're right. You know, if you have the room and in a neighborhood where you can put a beam up and put a big tower up and spend all the money and the effort to doing that, that's a really good way to get an increase of 3, 4, 5 dB. You know, the easiest way to get gain is to put a 2-element rotatable beam up. But that's really pretty hard too. And for each element, usually you have a driven element and a reflector. Then for each director that you add, you get another dB or so. Now, if you can't do that, and if you need, say, 3 dB more signal, and you have something like a dipole, which is what these Yagis and beams are measured against, all you need to do to get 3 more dB is to double your power. Go from 100 to 200 watts, and you can get 6 dB by doubling that to 400 watts. So you can get 400, 600 watt, 800 watt amplifier, and that can be equivalent to a multi-element beam that you put up, and all you need to do is to put a box on your operating position and plug it into the wall.
Yeah, we got a call, Walter. Let me check, see who's on the line here. Who we got? Oh. Let's see. Let me answer it again. All right, hello. Who's on the phone? Hello? Let's see. Phone. Hello, who's on the phone? All right, I don't hear anybody, so we'll just hang that up. We had one call and he was kind of holding there, but yeah. So this is an interesting discussion. 901-286-1116. So, you know, it might be better or easier to put a little amp in there instead of putting a big tri-bander up or something, you know. But I guess the big boys are going to have both. You know, they're going to have the tri-band beam with that 6 dB gain or whatever, or 5 dB, and then they're going to have their amplifier that has 10 dB, and you're going to start adding all that up. So I guess that's the big boys there. Martin, now I learned something about you last week. I didn't know. Here it is, Mr. MFJ owns a Maritron, builds the nicest, finest amps in the world, the most popular amps around the world, and Martin Jew does not even own an amplifier. Hello, who's on the phone? Hello? Well, he hung up on us. But Martin Jew does not even own an amplifier. Boy, if I was Martin Jew, I'd have me a couple of big amplifiers down at my house there. Okay, we're not going to answer that phone because it's the same number. So we won't answer that.
Well, you know, I'm in the same kind of neighborhood as lots of my fellow hams are, and you are too. You know, we put lots of power out and put a big antenna up, and they run us off. They run us out of the neighborhood.
Huh. Well, let me try it again. All right, hello.
Hey, Tom, this is Bill, WZ1L.
Hello, Bill, WZ1L up in Massachusetts. How you doing tonight?
Hey, Martin. Nice to see you again.
Bill, how you doing tonight?
My question for Martin, okay, is there was a question in regards to what the cobweb, the difference between a cobweb and a quad. I think that was from Bill W4 EWH. He wanted to know what the technical difference between the antenna and a quad.
Well, you know, quads in the past have normally been used as a directional multi-band antenna. I mean, it's like a 2-element or more, 3-element Yagi, and it's a directional antenna that you use a rotator to point it in the direction that you want most of your signal to be in. The cobweb is basically an omnidirectional, horizontally polarized, very flat, low profile antenna.
And you know, Martin, the quad too is usually a loop has to be a full wavelength, which means it's going to be quite a bit larger, whereas the cobweb is a dipole, it's folded.
Yeah, you know, that brings an interesting concept up. What if we try to make a cobweb into a 2-element antenna and make it directional? That could work.
Well, isn't that what they call a moxon or something like that, where basically you have a folded, true. You know, a folded dipole, folded like a U shape, and in the back half you got a U shape director.
You're right.
I mean reflector. So
you're right.
It'd be a little larger, but again, you'd have to rotate it.
But I have a question for Bill, though.
Yes, sir.
Bill, how'd you like that red beans and rice with some sausage?
Hey, that was awesome there, and I thank you for inviting me out to Orbeez there just so I could try it.
Well, you need to come on back down here.
I told Tom I got to come back. I got to get my AL80B, and I want you to cut the green wire.
Okay.
Well, hey, listen, I think somebody else wants to call in here, and I'll say thank you for your response there, Martin. It's always a pleasure to hear and talk to you there. So I'll say 7-3s this go around, and thank you and good night.
Okay. Well, thanks for calling, Bill. Bye.
Yeah, good night, Bill.
73s.
All right. So we're looking for what was that? W4 EWH. Every time I'd answer, you were not there. So try it again, W4 EWH. We'll try to get you. So yeah, my understanding is, and hey, the quad antenna was very popular back for sea beers many years ago. You see these big quad antennas up, and like you said, they were like 2-element multi loops, inside the your front spreaders, and then the same, I guess, multi loops in the back there. And let's see what we got here. Hello. Hello? Who's on the phone? Who is on the phone? Okay, not sure why we're not getting him. It's the same number. It's the 182 number. I don't know why we can't hear him, but he's not there. Hello? Who's on the phone?
Oh, hi. Bill, W4 EWH.
EWH, Bill. W4, Bill. Hey, Bill, how you doing?
Well, thank you.
Was that you that kept calling in and I never heard you, or?
Yeah.
Okay.
I don't know why. I just kept going dead.
Yeah. Okay. Well, how you doing, Bill? What do you got on your mind tonight?
Yeah, I had a question for the doctor. And I should ask you first, Martin. Either way, but I wonder if you could tell me what you prefer as the solution to wideband to dipole on, say, 80 meters. I mean, when I first got into radio, the MIT Radio Club had a dipole, a cage dipole that had like a 15-inch diameter, and they had gotten it to less than 1.5 to 1 all the way across the 80-meter band. But, of course, that's a lot of wire and a lot of work, and not everybody has that kind of space or that kind of wire budget. Are there bazooka antennas, or do you favor wide banding with a tuner?
Well, the easiest way to do it, just put a regular dipole up and use an antenna tuner just to tune it. There's not that much variation in impedance, yeah. And the tuner won't introduce that much loss into, small changes in impedance versus the trouble that you go to putting up a dipole that's very large in RF diameter. It's a lot of trouble to put up a big fat dipole, even though inherently it gives you a much wider bandwidth. You can make that difference up with a little bit more power. Where are you from now in W4 land? EWH.
EWH, uh-huh.
Yancey County, North Carolina.
Oh, okay. Where is that?
What part of the state's that in, Bill?
North Carolina.
What part of the state? East, west?
Oh, northwest. Up. Probably about equidistant from Virginia and Tennessee.
Well, Bill, we've got a house over in North Carolina. You ever heard of a little place called Tuckasegee? Probably not.
Well, the flying school that's the same as for the World War II. That's all.
Yeah, we got a home over in Tuckasegee. So let me go up to the next bigger town, Cullowhee. You ever heard of Cullowhee?
Nope, can't say.
Oh boy, okay. Let me go up. Let me head north to a little bit bigger city, Silva. You ever heard of Silva?
No.
Oh man.
Boy, I'm striking out today.
You're in northwest. You're in northwest North Carolina.
That's right.
Okay. Okay. You know where Waynesville?
40 miles north of Asheville.
40 miles north of Asheville. Asheville. Okay. We're about 1 hour southwest of Asheville. So we're down in the middle of Appalachians there. Well, Bill, I know what you're talking about. That it's kind of looks like a bird cage stretched real long, with multiple wires and all that. That just makes it real broadband for sure. And I don't know.
The other question I had for Martin was, I want to know why a magnetic loop is better than a regular loop made of wire. I think I understand it, but I'd like to hear his explanation.
Well, what's termed as a magnetic loop, the whole idea is that it's just tiny. It's small. It's the one that we have is 30 inches. And the regular loop is huge, takes up a lot of room. I mean, that's basically the big difference.
So Martin, I guess you could make a 30-inch loop out of wire and put your capacitor across it, but it like you say, you're dealing with milliohms. I don't know what a piece of wire would look like.
Well, if you take one that has a large diameter conductor, like a piece of house wiring, the resistance of that, even though it may be copper, is far less, far more resistance than an aluminum piece of tubing that's 1.05 inches in diameter.
Mm-hmm.
And that contributes toward the losses, and that's where all your RF energy is burned up as heat. So, the idea is to reduce the loss resistance to as small as you can, which means very large diameter loop, and it's just more practical to use 1 inch instead of something like a 4-inch loop. And let me mention one other thing. That one of my friends in cardiac rehab keeps saying where he lives. He keeps saying he lives 3 miles west of east.
3 miles west of east?
Yeah. His town is called East.
Oh, okay. I got you. I tell you, hey, Martin, hey, when I was a kid and I went with my dad to softball games, and we went up to Missouri to play a softball game, and we got lost, and we asked somebody how we got to that there from here.
Let me just finish the question.
Yeah,
I had
go ahead.
been told that a magnetic loop had some advantage in eliminating noise. I take it that's not the case.
Oh, no, it does. I mean, it's a magnetic loop is a very high Q antenna. I mean, on the order, if it's built right, if it's built like, we built a loop where all the contacts, there's no mechanical contacts, every connection is welded. I mean, those things will have a Q of 1,000 or over 1,000, which means any noise outside of that passband gets really reduced, plus the polarization of the loop will reduce the noise, and it has a donut-shaped radiation pattern, which means there's nulls in it, and you can rotate that loop to null out the noise.
Mm-hmm.
I see. That's good to learn that. I had not known that. That's something more to think about. Okay, I won't hold you. There's others probably want to talk to you, but thank you for your time.
All right, Bill. Thanks a lot for calling.
Oh, thank you for calling. I appreciate that, and I hope you get a chance to come down here to Mississippi and visit us. We would love to have you come and see us.
Oh, okay. You can show me your collection of boat anchors there on the shelf.
Oh yeah, if you're old-time ham, and I can tell from your call that you are, and you would recognize a lot of these pieces of equipment that I have collected over the years, equipment that I wish that I had when I was a novice, and just now able to afford them.
Well, let me just ask your personal opinion then. Do you think the Drake 2B is the most underrated receiver ever made?
Man, that Drake 2B was my dream receiver, and I have one now. I mean, it's an incredible receiver. It had 3 IF stages and a ferrite tunable IF filter. You could tune it. I mean, it was an unbelievable receiver. Drake 2B, right?
Yeah, I actually had one when I was a novice.
Man, that was pretty. I mean, you were in high cotton when you had a Drake 2B.
That's right.
Yeah. No, for the price, it was an incredible receiver. I agree. Well, 7-3, and thank you for your help.
7-3. Thanks.
Well, thanks for calling.
Thanks. All right, we'll maybe just a couple more calls here. It's getting late. Martin needs to go home. We'd originally only scheduled Martin for 30 minutes tonight, and our other guest, Emmett Hohensee, W0QH, couldn't make it tonight, so we just figured we'd talk about everything here, and I think we're hitting a lot of it tonight.
Well, I always enjoy talking to my fellow hams. I always enjoy going to Ham Fest and sitting down and talking about ham radio.
901-286-1116. Give us a call before we turn the phones off. Well, Martin, boy, it's Martin, I got me one of your new Ameritron AL80B amps. I'm looking forward to hooking that up and trying it out. And today, FedEx brought me an ICOM 7300 today. And I haven't even turned it on or hooked the power up to it. So I've got some new radios to play with this week, and I'm anxious to play with those a little bit.
Well, if I were to choose an amplifier, that AL80B would be the one that I would choose.
Well, we've got a phone call here. Let's see who we got. Hello, who's on the phone?
Looking forward to hooking that up and trying it out.
Oh, you're going to have to turn your volume down. Turn the video down. Who we got on the phone?
Oh, sorry about that. Too many places at one time here. My apologies. This is Roy, KI7PKL.
Give me that one more time.
This is Roy. I'm Roy. My name's Roy, and I'm in Portland, Oregon.
Yeah.
And my call's KI7PKL. And some things that I've been wondering about lately, and all of a sudden it dawned on me, I can just talk to the guy that knows right there. I'm looking right at him and ask him, what kind of bandwidth do you get with that cobweb amp? I live in a really small lot. At first I tried to be really stealth, didn't want anybody to know I was a ham, but I've spent so much time outside painting my house with my HT on my belt, talking to people on the Alaska Morning Net that I think everybody knows now. So I'm thinking about one of those cobweb antennas. I'm really fascinated by that, especially since they can go down to 40 meters. How much bandwidth do you get with one of those?
Well, I have to check with the guy who's working on the 40 meters. It's more narrow than the other bands, but you can fix that problem with an antenna tuner. And the SWR might be a little bit high in the section that you don't resonate it at, but it won't be so high that you can't use an antenna tuner to get the SWR down low enough where it's acceptable to your transceiver, and it won't, you won't get much loss in your power level.
Well, Roy, I think Roy is saying he's in this an apartment type setting and can't put a very big antenna up there, out there. The cobweb that does 20 through 10, the sides are just 9 feet. It's very small. Now, if you want the one with 40 meters on it, it's going to be quite a bit bigger. Martin, what do you think? It's probably double the size at least, isn't it?
Isn't it about 17 feet or something like that?
Yeah, it's something like that. If you take a full-size dipole and divide it by 4, that's how long each side would be.
Yeah, I actually have a backyard, so it's not as bad as an apartment, but it's a really small backyard. Your backyard's about 40 by 50 feet, and neighbors, lots and lots and lots of them on all 3 sides. So Well, I don't know. I'm really fascinated by that cobweb. It looks cool. It looks like one of those might fit in my backyard. So might be a way to get on all the bands. So.
And you know, Martin, like you said, I think any antenna tuner built in any of the new radios now, it'll probably tune that cobweb anywhere on any of the bands.
Yeah,
I'm guessing.
it will. And let's see, what's the name of that caller? And
that's Roy, KI7PKO in Oregon.
Okay, hey Roy, you might want to just try one out. If you get it from us, try it out. If you don't like it, send it back to us. We just, if you're not happy with it, we'll make you happy. Just try it out and see if you like it or not.
Well, there's a real possibility of that. It's not real high priced. It seems to have all the stuff, and yes, I could fit one in my backyard. So, DX contest is coming up in about a month, and I want to be on multiple bands, assuming they're even open. But got to have an antenna. It doesn't matter, right? So, I just might give that one a shot. I'm experimenting with a couple dipoles right now. I've got your 20-meter dipole up. I just got back on the air last week, got the 40-meter one coming, and I may try a G5RV here at some point in the near future, too. So I'm just trying different stuff, having a lot of fun doing it, too.
Okay, well, G5RV works good, too.
Is that one of those things where there seems to be a lot of controversy about that antenna. Some people love it, say they get great SWR, they hardly even needed their tuner. Some other people absolutely hate it. Is this one of those things where you just need to follow the instructions? Is that where the divide is there?
Well, as long as you can get power into something, whatever that may be, can be a piece of wire, can be a dipole, can be a vertical. If you can get power into it, it's going to radiate.
Yeah.
And it doesn't hardly matter what it is. It's just easier to get power into some antennas. And when I say things like that, getting power into it is not always a trivial thing, because some of that power is lost in the device that allows you to get power into it, like an antenna tuner. But if you take something like a G5RV, well, let's don't even call it a G5RV. It's just a dipole. When I say dipole, what I mean is two lengths of wire that's equal on each side. Doesn't hardly matter how long it is, but then it's fed with a low loss transmission line like a 450 ohm ladder line. Now, it's better to make that dipole so that it's kind of resonant on the lowest band that you want to operate on. And then all the other bands above that higher in frequency should operate very nicely with very low loss if you feed it with ladder line. Now, if you make it too long, the loads might break up into multiple and smaller loads, but that might be an advantage too, because you can operate and talk to and listen to areas that you might not be able to with something like a extended double ZEP that's directional and has one strong lobe in one area. So if you're more interested in just general operating, just a doublet, which is a dipole, equal length antenna on each side fed with a low loss ladder line, but you have to have a way to match that ladder line to your transmitter. In other words, an antenna tuner. Now, you can use an automatic antenna tuner or a manual antenna tuner, which tends to have a much broader matching range. I hope I answered that question for you, Roy.
Yeah, I think you did. And I have I just bought an FT891, and I got the automatic tuner that that they make for it. And I've been looking at some of yours too, and just debating, a lot of different things and ideas. I do not really know what I'm going to end up with here. I may end up with one of your manual tuners, and who knows what. I don't know. It's fun experimenting right now, though.
Well, the fun of it all is that try it out. Just try it and see what happens. And if it doesn't work the way you want to, try something else.
I found, Martin, that you can just about put anything up and it'll work.
Absolutely.
Yeah.
Just got to get some power into it. It's going to go out somewhere.
Very cool. Well,
Roy,
Martin, thank you very much. It's really awesome pleasure meeting you. Thank you so much.
Thanks for calling, Roy.
Oh, it's so nice to meet you. Thank you for calling.
So now, Martin, I saw in a chat room they were talking about a 30-day no matter what return, but if I'm not mistaken, tell me here, I thought the MFJ no matter what was a year.
Well,
am I right or wrong on that?
Well, the 30-day no matter what is that you don't like it, you send it back no matter what happens to it.
Okay.
But within a year, we'll fix it for you, or give you another one at our discretion.
So, and that's what I was asking Richard, and I think I got the right answer. For instance, one of your auto antenna tuners, it might be pretty sensitive. I asked him, I said, what if it gets hit by lightning? And I think in the first year, y'all would probably cover that.
Yeah. I mean, if you're driving down interstate, well, no, you go up on 45 through Tupelo. If you were driving, I forgot what you were driving, but if you're driving in your pickup truck and it fell out the back of your pickup truck and somebody ran over it, we'll fix it or give you another one.
Well, that's, man, you can't beat that right there.
In that case, it'd probably be better for us to give you another one than to fix it. If
I'd hate to fix a tuner that somebody ran over. Yeah. Oh, it for sure. All right. Well, look, guys, it's 9:42. We've kept Martin really, really long tonight. I've really enjoyed all the discussions we've had tonight, guys, and we're going to let Martin go home. I'll turn Hangout on here in a minute if anybody wants to get in Hangout and for another 15 minutes or so. Martin, thanks so much for coming on tonight. And hey, Ham Radio's got so many topics that we'll have something to talk about next time.
Okay, well, thank you for inviting me, and thank you for everyone who called in. And, if y'all ever come down closer this way, come by and visit us. And if you turn on Hang Up pretty quickly, I'm going to finish the stuff I got in my coffee cup before I go home.
Well, Betty's going to probably get mad at you if you keep staying out late like this. Just tell her if she don't believe where you are, tell her to tune in and watch, okay?
Oh, she's watching right now.
Is she? Well, I'll say hi to Betty out there and say hello to Betty. We'll dedicate the show tonight to Betty.
Well, but she would like that, and she's probably glad I'm out of the house.
All right. Martin, 7-3, go home.
Okay.
And we'll talk to you later. Good night.
Okay. Bye. See you.
Goodbye. All right. So that was Martin Jew, the founder and president of MFJ Enterprises. I think we hit on a lot of topics tonight. I think it was a real interesting show tonight as far as all the things we covered. Let me bring Hangout up. I'm going to see if anybody's on Hangout. It may be a little late for everybody. They may have all gone to bed, but let me try it and see. Well, I think I'm the only one in Hangout, so unless I'm on the wrong Hangout, I don't know. All right. Oh, we didn't ever post the link for the Hangout link, so let's see. Let's see if I can post the Hangout link for you. you want to join us, here's the link. Oh boy, I'm having trouble getting it here. Copy, paste, okay. All right, there's a Hangout link right there. If somebody wants to join us on Hangout, just click on that link, and it looks like we got Roy here. Roy has joined us. How you doing, Roy?
Hey, I'm doing okay. Just enjoying the show.
Yeah,
and
we got Roy there.
enjoying the
Okay.
video chat thing too. That's kind of cool.
All right, we got Roy in there. I forget where you from, Roy.
Portland, Oregon.
Portland. Okay. Oh, you're the one that called in a while ago.
Yeah.
Yeah, K7 PKO up in Portland. Okay, cool. All right. Well, let's see if anybody else joins us. We'll give them a couple minutes here, and if they want to come in, we'll talk to them. If not, we're going to go get a peanut butter sandwich in a minute. Let's see. Peter AC4PS asked a question a while ago, and I missed it. I'm trying to think what Peter's question was. I'm looking back through the chat. Oh, he's talking about putting the cobweb in a vertical plane. Well, I think it might work in a vertical plane, but that would make it directional. It would make it directional, two different directions. You know, broadside to the square dipoles. The neat thing about the cobweb when it's horizontal is it becomes omnidirectional and will radiate in all directions. If you put it vertical, you're going to radiate in two different directions, front and back, and you'd have nulls and you'd have higher spots, and you'd probably have to rotate it like with a rotor. But Walter and I, we're building one out there, and we're going to see how it turns out. And Walter, I got another box today to put the feed point in. The little box we put the feed point in, the coax connector on, and all the wires came in. I got too small a box, and we were really cramped in there to try to hook everything up. So I got a little bit larger box for the feed point. We're going to build one. I would say at the price that you can buy the cobweb for, that you know it works, is not much more money than it would be if you want to go out and buy all the material and then try to build one and have an inferior product. For example, the cobweb that you might buy, it has fiberglass spreaders on it, whereas Walter and I were using a half-inch PVC pipe, and a half-inch PVC pipe is not going to last very long, to tell you the truth. And we got, looks like we got Bill joined us. Let's see, we got Bill, we got Mark. We got Bill, Mark. Hey Bill, how you doing, Bill? Bill, I'm not
Hey,
here.
FQB, where you at?
Who you talking to? Who was that? Was that you, Bill?
Yeah, I was asking where Mark FQB was. I see his head.
Yeah.
Yeah, I'm here. Man, this night went fast.
So
So
tonight,
did you go to the ham convention at the ham thing this weekend there, Mark?
Which one?
The one in Ohio?
Oh, Maslin?
I don't know. That I saw something in the chat room there that they were there was a ham thing up there, and it was north of Dayton.
Oh, I know the date. Well, I think there's a try one down there, maybe. I have to look at the ARL website to see what other one. I know the one in Maslin, Ohio.
You?
well, we went a little late tonight, so that's probably why we don't have as many people in Hangout. We got Roy, Mark, we got Bill. So, did you guys enjoy listening to Martin? He's a cool guy to listen to. He got a lot of stuff, don't he?
It was very interesting.
Yeah.
you know, I really envied you and Walter driving down there on Friday. But as you said, it was a football weekend, so I'm sure travel down was a little touchy, if you will, there.
Man, I'm gonna tell you, Bill. You know what I went through. I thought the GPS is taking me back, right? And Walter goes down there a whole lot, so Walter knows the area. And Walter says, "No, go right here." I said, "Well, the GPS is saying left. Now go right." So we go right. We go right. And guess what? It takes us right down through the campus again. But you know, it was.
You went back to the campus.
We went through the campus, but I want to. All time, you know, home game, and hey, now Martin, Martin tries to leave town when there's a home game. That's how crowded the city gets. But it was interesting for me. We went down there, and I saw probably 1,000. Well, the people go out there and they tailgate and they cook and they visit and they, you know, whatever they do. And here, the thing that impressed me so much was. Right. Every single one of these tents, these tailgating tents out there, they had a 6-foot pipe stuck in the ground with a dish dish on every single tent. And those people bring in big screen TVs and put in those tents. I don't even think they go into the stadium. They just watch it out there in the you know, in the tents.
That's what it sounds like, huh?
Man, I mean, it was. I've never seen that, man. I didn't even know you could get a dish TV for, you know, like a one-day deal. Obviously, Dish comes out there and installs it the day before. I mean, no one was in the tents, but all the Dish TV things were stuck up at every single tent out there, man. Oh man! Yeah.
I see Kathy's back home, so I guess she's huh, Tom?
Yeah, she back. She helped out tonight, so that's good. And the show will run better when she's here.
Yeah. But the you did the other day.
The satellite. I mean, the space station contact. Yeah.
You said that's going to be in a couple weeks.
Yeah, I'm not sure when we'll do it. Maybe the next couple weeks. Also, our astronaut friend Doug Wheelock said he'll be on the show anytime, and maybe I'll schedule a show with him and then just run that little 8-minute school video with him. You know, he's probably seen
those kids asked some pretty interesting questions too.
Yeah, boy, they ran them through fast, but they knew they didn't have a lot of time.
No, I just say that anybody who's, do you want to upgrade your Skype? Don't do it until you know what you're doing.
Yeah, man, Microsoft has taken a lot of heat. They've got a lot of bad. They've got a lot of bad comments. Probably 95% of Skype users are upset with them with this new version. And the new version is a cloud-based Skype. You know, so I think it'll be okay. I think people just aren't used to how to use it. It should work okay.
Oh, I'll send an email to my nephew. He works for Bill Gates out there in Redmond, and I'll ask him figured out what's going on there.
Yeah.
If he else has a problem, we can at least help him out.
Well, I think there's a way to keep the old classic Skype, but Martin hadn't figured out yet how to do it. And since I'm not there,
not being able to see what he's looking at there. I mean, you know.
See, I've got
my Skype up thing.
I've got the old Skype running here in the studio. Now I do have the new Skype in the office in here, and I saw it. It does look much different. Both probably.
It does look different, but is that the little little bar up there on the top there that gives you the option for file or contact or
I don't remember. It doesn't have the contacts on the left side like the old Skype does.
it doesn't?
No, you got to click a little bitty box that you almost need a magnifying glass to see, and then it'll open up your contacts. And I think they're storing now your contacts on the web, and I don't know. But we'll get it figured out. Cliff says how many? Let's see. Cliff says how many PCs do I have in front of me? He must have saw the side shot. Let me see. We get the side shot back on. There we go. How many PCs? Well, Cliff, we've got this PC here, and we've got this PC here. Let's see. This one basically I bring our phone line in on it, and any kind of web pages and stuff I want to. This PC here is running. Hex Chat or the chat room, and it also is running the encoder that we send the audio to the shortwave radio station. So I've got that running on this one. This PC right here is our Wirecast encoder. Basically, it's the thing that streams the show, and everything on here is software driven. I've got like 100 different here, and you've got different layers and levels and so forth. And then this PC over here is for Skype, and right now I got the Hangout guest coming in on it. And then the PC behind that over there, Kathy usually sits back over there with another PC and watches the chat room. And then we got another couple PCs over there on the desk that are off right now. So we got about 4 or 5 PCs that are kind of networked here with some special software that allows us to do things. And the neat thing about it, the program here is, and you might have noticed there's four mouses here, 1, 2, 3, 4. People say, well, why don't you put a KVM switch or something in? Well, I'm so interactive on all these at the same time. A KVM switch would just cause me problems to have to flip back and forth. So right now the best I'm doing is that. Oh, and we got a big screen monitor on the wall straight ahead that I can see the show on up there. So, but the neat thing is with this program, I can do a lot of things. For instance, I can be at the beach right here. Hey,
he went to Bermuda.
So yeah, I can be at the beach right there, or look, let me see. Hey man, I can be, hey look, I can be on the space station right here. How you like that? I can be on the space station, and I can be anywhere actually. Now, if we want to go to our Studio B, there's Studio B.
A red screen, and you only have a head. Your shirt will blend right in with the background. Yeah, there's Studio B right there. Notice the little monitor right there. If you notice the little monitor back here, see, I'm on the monitor back here. Right. I can bring it up on different monitors, and or if you really want to get into a fancy ham shack, I can get in here, and every now and then I'll go back here and reach up here to the matchbox here, and turn some knobs a little bit, and yeah, that's a virtual ham shack. You can have $1 million ham shack right there.
Yeah, if I want to bring pictures in, I can bring pictures in. There's me, 1964. Boy, that's what a novice station looked like. And, there's a side camera over here. And we can put all kinds of little things in here. We can put various different, pictures and things like that. Or we can put lower thirds on, whether it be like Katie or Tom or whatever. The phone number's still on. I can take the phone number off. Let me take the phone number off. And let's see. Just do a lot of things. It's a lot going on here, actually. Let's see. Let's see what's in the chat room here.
What the fuck there, Tom?
Nope.
See.
I gotta see what my chat.
Yeah, yeah. Let's see.
There's chat room up. Let's see if there's anyone didn't do anything in there. You know, I'm wondering. I'm talking some right now. That came right over to me.
Hey guys, there's not many left out there. Here's there's some radios I'm getting rid of. So if anybody's interested, I'm probably going to look for about $800. I really hate to get rid of it, but I just bought me a new Ameritron AL80 amp here and a new ICOM 7300, and I've got some other radios. This one was taking too much room. It takes about 4 foot on my desk, and I haven't used it in a while. So, you know, Kathy tells me go out and buy anything I want to buy. Just get rid of some of the old stuff. I really hated getting rid of this. I've had it so long, and it's such a nice radio. It's a 180 watt, you know, 160 through 10 meter radio, and it's got your external VFO and the external speaker, and there's a tuner, and it's got the CW filter installed. It's got the 12 volt option installed. It's a 110 volt radio. It's 180 watts PEP. So anyway, I've got it sitting on the table over here, and you know, if anybody ever gets interested, I've had a lot of people say they're interested in it. I'll probably get rid of it. I don't have a lot of room to put it or set it around, and I don't want to put it in an attic where it get all dirty, and I don't want to box it up where, you know, I won't see it or anything like that. So I've got it out, and if somebody does want it, you know, I'll turn loose of it. Well, guys, it's 10 o'clock. Yeah, what were we going to say, Bill?
Yeah. It's 11 here, and I need to get to bed, so I'll say 73.
Okay.
We'll see you soon. Hey, if you wanna test your radio there, give me a text on my phone here, and turn it on and see if I can find you.
Yeah, you know, tomorrow I'm sure I'll probably start hooking it up. It took me an entire day to. It took me. Let's see. I've got a picture of my bench here. Let's see. There's the 7300 in the center. There to the left, there's a TS 2000 to the left, and there's a FT 991 to the right. So there's a Kenwood, an ICOM, and a Yaesu right there to compare. And then there's a Kenwood TS 570 on the top shelf here. So and then there's kind of a closer look at the desk. So I've got there's a AL 811H on the right, and there's the AL80 I just bought and put there on the left. I've got to hook those up. But I had so many cables. There's so many coaxes and 12 volt cables and speaker cables and keying cables. And I don't know how this stuff gets so tangled up, but when it's back there for a year or two, man, it's the biggest rat nest you ever saw. It took me hours just to take every cable out and untangle all that mess, and then hook it all back up and make room for the two new pieces I'm putting there. So that's what the AL80 80B looks like right there. So maybe tomorrow I'll get it hooked up here. Okay, Walter, I see you, Walter. Are you going to be around tomorrow afternoon? I'm thinking I'm good to play antenna or 7300. Yeah, I'm around, Walter, and I'll be working on that antenna and making some improvements to it. Walter, I'm going to weld tomorrow. I'm going to weld the little extension on top and an eye bolt on top. Now, I've got some eye bolts to put in each of the feeder arms, so we can put a little rope to hold those feeder arms up. So, hey, we're ready to go, man. Ready to go. So, and I want to play with the 7300. I'm itching to play with the 7300, but right now I'm thinking more peanut butter sandwich. I'm hungry.
How's everyone?
Hey, how you doing there, Douglas?
Doing okay.
How you doing with your Pixie? How you doing with your all-band Pixie? How you doing with your all being Pixie?
Just need to get a perforated board or a proto board to put together the VFO on.
Oh, okay. So you're gonna build your VFO on it. Now, did you say you're gonna use a pick or something, or what are you gonna use for? Are you gonna use Arduino, or what are you gonna use for your VFO?
The VFO is going to be using 9851.
Yeah, in fact, I built several of those with the 9851.
I see 16F628A.
Yeah, I built that using that that board, and boy, that thing is really stable, and it really is. It's a neat little VFO. Neat, yeah. So where are you going to put all your where are you going to put your filters, your 160 through 10 meter filters? You going to put them on perf board?
I'm using these as cases.
Okay. And you're going to switch those in and out of the circuit, I suppose. Yeah.
And I'm actually contemplating building a selector switch array.
Okay. Cool.
For the low pass filters.
Well, you know that they make a little wafer switch that's got 2 poles on it. You know, a little double wafer, and that would be kind of cool for your filters, because you'd probably want to switch. You'd probably want to switch both ends of your filter, the input and the output of the filter, on each filter. So I would think you'd need like a double pole, maybe rotary switch.
Yeah. I need one that has 9 positions.
Uh-huh. Well, I used to have junk boxes here full of stuff like that.
Yeah.
But nowadays, I'll tell you, if you go on eBay and search for a 9-position rotary switch or whatever, boy, it'll pop right up there, and it'll be $1.29 and free shipping, and man, you can get anything you want out there now on eBay.
Yeah.
Well, good luck on that, and keep us posted how it's coming along here. All right. Well, I'm gonna get out of here and get me this peanut butter sandwich, and maybe tomorrow play with new radios. Thanks everybody for watching and joining the hangout tonight. And we'll see you later. Good night. Good night, everybody. Good night, Bill, Roy, Mark, Doug. Good night, everybody.
Thanks for doing the show.
Yeah, man.
72, Tom.
Yes, sir. All right, so that should do that. There we go. Okay, well, guys, we're going to get off here. 73 to everybody, and we enjoyed having everybody with us tonight. We'll see you next Tuesday. Help us spread the word.
So you're saying I can ask this cat any question?
The cat is connected to the computer. You just type in the question, it will read his mind. There the answer comes.
You're the man! I've been looking for this for weeks.